All right, hi everyone. This is the third example of chapter 1. It is question 3. It is on page 26. Let's read the question first. Question 3. Calculate the electrostatic force between an electron and a proton separated by 0.53 multiplied by 10 to the power minus 10 meters. So that's part A. Part B, calculate the acceleration of the electron at that moment. Now, just to specify, in that question, we are not talking about the direction yet. We are only talking about the magnitude. But we will mention the direction, just that it's not implied in the question. So we have a proton and an electron. There's a certain distance between them. The distance is denoted as r. Now, r stands for the radius generally. So let's say if you were to draw a complete circle around the proton, well, the radius or the outer circle will touch the electron in this case. So that's why the letter r or lowercase r is used. All right, so we have a proton and an electron. The proton has a charge of E, plus E, because it is positively charged. The electron has a negative charge, minus E. Now, because these two charges are different, one is positive, the other is negative, they will attract each other. Now, if you want to see in which direction the force will be applied, we need to look at each object individually. Since both of them will attract each other, due to Newton's third law, both of the force will be pointing in that direction. So, just like Newton's third law state, a reaction has an equal and opposite reaction. Both forces will be of the same magnitude, but in exactly opposite direction. Now, if we want to calculate the magnitude of either force, we need to use the Coulomb force equation. So in this case, the absolute value of the force is equal to the Coulomb constant multiplied by the first charge multiplied by the second charge divided by the radius square. Now note that I put absolute value for the charge to remove any negative, because as you will see in the coming example, it is way easier, at least in my opinion, to calculate the magnitude and look at the graphic or at the problem itself in order to determine in which direction the force will be pointing, all right? So if we only look at the formula, it can be misleading, all right? It's way easier calculate the magnitude, then we determine the direction of the force, all right? So in this case, again, the direction is not asked, but it's a good idea to prime ourselves into thinking about these aspects, because in the next few questions, we will need to take that into consideration. All right, so we input all the value, we get 8.2 multiplied by 10 to the power minus 8 Newton. All right, so the unit did not change here. We're still talking, the force is still in Newton, no surprise here. Part B, calculate the acceleration of the electron at that moment. Now, the rule of mechanics did not change. F is equal to ma. We're looking for the acceleration. We just need the mass in this case. We already found the force. So the mass of the electron is 9.11 multiplied by 10 to the power minus 31 kilograms, so it has a tiny mass. And if we look at the acceleration, we input all the value. The acceleration is equal to 9 multiplied by 10 to the power 22 meter per second square. Now, one of the things I want to highlight, and it will become more obvious in the next few examples, is when we calculate some aspect of the kinematic, like the acceleration, acceleration is not constant. As the proton and the electron move away, the radius will change. If the radius change, the force change. If the force change, the acceleration change. So we cannot use the normal law of kinematics when we were dealing, let's say, for a falling object. We're throwing a baseball in the air. Well, because the Earth is so big, the force is not completely constant, but the change is so little that we don't even bother with it, all right? But when we are talking about electron, the change can be quite dramatic, and in other words, we cannot use the kinematic equation. We will see in a few chapters that we can still use the energy formula in order to determine the velocity at a certain point, all right? So that's it for this example. In the next example, we are going again to be talking about the force between two charges. All right, so see you in the next video.